x equals to a cos t plus log tan t by 2 and y equals to a sin t. We need to find dy by dx without eliminating the parameter t. So x equals to a into cos t plus log tan t by 2 and y equals to a sin t. Let's differentiate these equations with respect to t. We get dx by dt is equals to d by dt of this thing is equals to a constant, so common, a into d by dt of cos t is minus sin t plus d by dt of log tan t by 2 will be 1 by tan t by 2 into sec square t by 2 into 1 by 2 from using chain rule, which is further reduced to a into minus sin t plus 1 by 2 cos t by 2 sin t by 2 into 1 by cos square t by 2, 1 cos cancelled, and this is reduced to 1 plus, this is 2 sine theta cos theta form, which will be sine 2 theta, so sine 2 into t by 2, this is 1 upon sine t, taking LCM minus sin square t plus 1 by sine t, this is equals to a cos square t by sine t. Similarly, differentiating dy by dt equals to d by dt of a sin t equals to a cos t. Now dy by dx equals to dy by dt upon dx by dt. Replacing these values in this equation, we get dy by dx equals to sin t by cos t, which is equals to tan t, which is the final answer.